if we consider this gorilla tripod as our Cartesian coordinate system in three-dimensional space, this is x-axis, this is y-axis and this is z-axis, then how to find the position vector of a point A in space such that wave vector is making angle 60 degree with x-axis, 45 degree with y-axis, and magnitude of wave vector is 10 units. So today we will find it. I have taken this beautiful problem from this book Ncert Exemplar Problems for class 12. This problem is important for CBSE 12th board exams. So before start solving today's problem, I would like to request you, if you are enjoying my videos, please do subscribe to my channel and share these videos with your friends because it will help to grow my channel. So without wasting any time, let's start solving this problem. So here is the problem. So first we will draw the diagram. This is the Cartesian coordinate system. Say this is x-axis, this is y-axis and this is z-axis, and say this is line OA. This is the point A whose position vector we are going to find. Now here in the question it has been mentioned that this much angle is 60 degree. See previous page. Wave vector is inclined at 60 degree to x and 45 degree to y. So here this much angle, wave vector is making angle 45 degree with y. Now we are going to use the concepts what we have discussed in our very first lecture, lecture number 1 of our three-dimensional geometry lecture series. There we have discussed that here if a line makes an angle alpha, beta and gamma with x-axis, y-axis and z-axis, then alpha, beta, gamma are nothing but direction angles, and cosines of these direction angles are direction cosines. And also we have learned that any line in space have two sets of direction cosines. If alpha, beta, gamma are direction angles of a line, then pi complement of alpha, beta and gamma, that is pi minus alpha, pi minus beta and pi minus gamma are also direction cosines of that line. So we get for any line in space two sets of direction cosines. Why I am telling this? You just understand while we solve the problem. Okay, let the line wave vector makes angle alpha, beta, gamma with coordinate axis. Okay, so therefore alpha equal to 60 degree and beta equal to 45 degree. Therefore direction cosines of the line wave vector are cos alpha, cos beta and cos gamma. Okay. Equal to cos 60 degree, cos 45 degree and cos gamma. Now what are the values? We know that cos 60 equal to half and cos 45 degree equal to 1 by root 2, because we have remembered these values. Okay. Now Again, from lecture number 3, we know that the relation between the direction cosines of a line element is L square plus M square plus N square equal to 1. We know L square plus M square plus N square equal to 1. Where element are CPV space. These are the nothing but element L, M, N. Say. So cos square 60 degree cos square 45 degree plus cos square gamma equal to 1 implies cos 60 means half, so here 1 by 4, cos 45 degree equal to 1 by root 2, so 1 by 2 plus cos square gamma equal to 1 implies 1 plus 2 plus cos square gamma equal to 1 implies cos square gamma equal to 1 minus 3 by 4 equal to 1 by 4. Now, what is the value of cos gamma? Plus minus 1 by 2. See here what we have discussed, that any line have two sets of direction cosines. Here see cos gamma, value of cos gamma is plus half or minus half. So here we are going to take one value, that is positive value. Let us take cos gamma equal to half. Therefore, direction cosines of wave vector is see previous page, cos 60 cos 45 degree, so half 1 by root 2 half. So also we know that if L, M, N are direction cosines of a line in space, then LR, MR, NR are the direction ratios of that line in space, where R is nothing but the magnitude of that line. Here wave vector is given and magnitude of wave vector is given as 10 units in the question. See previous page, 10 units is the magnitude of wave vector. So here R equal to 10. So therefore direction ratios of wave vector LR, MR, NR equal to 10 by 2, 10 by root 2, 10 by 2. So here 5. Here if we multiply by in the numerator and denominator with root 2, so 10 root 2 by 2, so 5 root 2, and here 5. So we have derived the direction ratios of that line wave vector. Also, if you go through my all previous lectures in our three-dimensional geometry lecture series, you know that if a line in space wave vector say is given, then if its direction ratios are a, small b, small c, then this vector can be written as ai cap plus bj cap plus ck cap. That is, direction ratios of the line are nothing but the components of this vector along x-axis. Direction ratios of a vector, wave vector, are nothing but the components of this vector along x-axis, y-axis, and z-axis, and also They are nothing but the projections of this vector on x-axis, y-axis and z-axis. That three particular points we have discussed in our previous lectures. So you should not skip any lectures to understand all the concepts. So therefore, the position vector of point A is, here the direction is this, the 5 I cap, 5 root 2 j cap plus 5 k cap. So that we are going to find the position vector of a point A. So answer. So we have reached to the end of today's video. Hope you have enjoyed this video. If so, then please do subscribe to this channel. Hope to see you in my next video. Thank you for watching.